A lot of the fun of flying my powered parachute is that I can look down at the earth below and come to a little better understanding of what I learned in college about 1,000 years ago as I was studying the science of geomorphology, or how the landforms that we see around us today were formed. A good example of that is Lake Mountain, just to the east of Cedar Valley. Taking off out of Cedar Valley and turning east, we look out on the horizon and see the Wasatch Range. The Wasatch Range is actually the western edge of what's called the Colorado Plateau. That's the boundary line between the Colorado Plateau and the Basin and Range province farther to the west, or where Cedar Valley is located. The Basin and Range province runs all the way over to the California border at Death Valley. The hills we come to just after we've turned east out of Cedar Valley are the very north end of Lake Mountain. Lake Mountain is a fault block mountain in the Great Basin that is inclined from a low point at the north to a high point towards the south. It's part of a very complex story. The North American continent has been pushed and shoved and pulled and tugged, and the Great Basin and its fault block mountains is just part of that story. I'm going to plug a little video in here that helps to explain that whole process.
The Basin and Range Province is a broad region of parallel north-south oriented valleys, known as basins, and surrounding mountain ranges. The province was created as this area of the North American plate was stretched, fractured, and broken into hundreds of mountain blocks and faulted valleys. Let's watch a hypothetical block undergo early rifting. Both sides of the area, under tension, pull apart evenly. Hot material from the asthenosphere migrates upward, causing the land surface to rise and break along fault lines. The heat from the asthenosphere warms the upper mantle and lower crust, facilitating ductile deformation, thus allowing the lower part of the plate to stretch and pull thinner like taffy. The buoyancy of the warm material, in concert with the thinning of the plate, contribute to continued upward movement, creating fault-bound valley basins and up-faulted mountain ranges.
And so Lake Mountain is an example of one of the places where the Earth's crust, a block of rock, was shoved upward, while Utah Valley and Cedar Valley are places where blocks of earth dropped downward. But like most other things, it's a lot more complicated than that. Not only were there periods of time when the continent was being stretched apart by great tectonic forces, crustal plates on the earth moving from one place to another, it was also at times under compression, where the rock layers were being squashed together. I'll try to add another illustration here to show how that works. So as this diagram shows, when the crust of the earth is compressed, faulting occurs, folding occurs, all kinds of stuff happens that makes a complex interaction of rock and erosion and everything else it takes to form our planet. And so what we see as we fly over virtually all of western Utah is a very complicated, complex story of uplift, compression, tension, shoving, pushing, twisting, turning, faulting, breaking, crunching, and it finally produces the landscape that we see as we fly around here. Climbing higher, we're just about to reach the summit of Lake Mountain, which is right around 8,000 feet above sea level. And looking at what I've seen so far, this part of the mountain doesn't seem to have undergone a whole lot of deformation. The rock layers, in this area at least, seem to be pretty uniformly horizontal, layered, A little bit of bending and twisting perhaps in spots, but not a generally complicated chunk of geology. In quite a few places in the Great Basin, there has been volcanic activity, but I didn't see any sign of any igneous rocks or other obvious signs that there's been any volcanism in the area of Lake Mountain. And then at the top of the mountain, there's all kinds of electronic equipment, TV transmitters, microwave towers, you name it. Off in the distance there's a little round circle of cement with a white tower poking up out of it. That's the Fairfield VOR, called an Omni Range Station for navigation for aircraft. I've heard tales that Kent Price has even landed his machine up there. There are actually quite a few places where you could land. I didn't try it this time, but who knows? Maybe someday. So anyway, I crossed over the top of Lake Mountain and then began descending back down towards Utah Lake. This is a heavily eroded countryside here. All kinds of little canyons and channels where water has tried to wear the mountains away. One geologist has said that it looks like the Wasatch Range is eroding by about 1/4 inch a year overall. That's probably about the same out here on the surfaces of Lake Mountain. You can see the network of small canyons where water has been carried away. I'm sure there's a lot of faulting down there from past earthquake activity, and many of these canyons will follow those faults because it's areas where the rock was broken and weakened by earthquake faulting, and so it's easier for erosion to occur in those spots. I topped my flight over Lake Mountain out at just about 8,400 feet above sea level, and descending down, picked out one of those canyons and just sort of slid down through the canyon to head back towards Utah Lake. At the lower end of each of these canyons, we come across what's called an alluvial fan. This is a place where dirt, sand, rocks, whatever else has been carried by water out of that canyon flows out onto a surface where it's starting to level out. And so this material spreads out in kind of a fan shape. Over my left toe there, you can see the alluvial fan. It's cut through with a few gullies and washes, but that material down there came from up at the top of the mountains. At the top of the alluvial fan is the heavy material, larger rocks, and then gradually it becomes lighter and lighter and lighter material until by the time it reaches the shore of Utah Lake, we're down to very fine sedimental material like just mud mainly and very light sand. Continuing to fly out over that alluvial fan, you can see how the material has spread out wider and wider as it's gotten farther and farther away from the mountain. And now there are new erosional channels being cut through that material as even it is carried away, eventually going to fill up Utah Lake. Now, looking back up towards the mouth of one of those canyons, you can see the spread of the alluvial fan becoming wider and wider as we leave the area of the mountain. As we flew out towards the lake, some more things popped up that illustrate why the geology of the western United States is so fascinating. Look at this. What kind of structure is this little thing? You can see that the rock layers there are just about vertical. So what's the story of this? This looks like it would make a really good subject for a master's thesis in geology. There's no end of stuff we can learn out here. And the material in these alluvial fans is valuable in many, many ways. Sand, gravel, all sorts of stuff that we mine and use for everyday life, the construction that's going on in Utah right now. Gee, there's just no end to this story. And that's what makes it so much fun. And finally, one more mysterious little tidbit. What's this? Is that man-made? Is it natural? What is it? Gee, there's so much to learn. Let's keep learning, okay? One more reason why flying is so much fun. The things we get to see. Wow.